For as long as humans have walked this planet, we have asked one of the biggest questions in all of science and philosophy. Does the universe have an edge? And if it does, what lies beyond that edge? This is not just a thought experiment. It is a question that astronomers, physicists, and cosmologists have studied for centuries, using telescopes, math, and the most powerful theories in physics to find answers. Today, we are going to dive deep into this cosmic mystery, step by step, from the earliest ideas of a small closed cosmos to the modern discoveries that rewrite everything we thought we knew about space, time, and the limits of reality. Long before telescopes or satellites, our ancestors looked at the sky and imagined a universe with clear edges. Ancient civilizations thought the Earth was flat, with a solid dome overhead, holding the sun, moon, and stars. To them, the edge of the world was a real place, where the ocean fell off into nothingness, and the dome met the land. These ideas made sense, because they matched what people could see with their own eyes. No one could travel far enough to prove otherwise, so the universe felt small, bounded, and easy to understand. But as human curiosity grew, we started to question these simple stories. We realized the Earth was round, not flat. We learned that the stars were not attached to a dome, but were distant suns, scattered across an unimaginably large space. Slowly, the edge of the universe began to fade from a physical wall into a mystery no one could easily solve. By the 20th century, everything changed. Astronomers like Edwin Hubble made a discovery that shook the foundations of science. The universe is expanding. Galaxies are not sitting still. They are moving away from each other, faster and farther, every single second. This expansion told us something critical about the Big Bang, the event that started our universe roughly 13.8 billion years ago. If the universe is growing larger today, it must have been much smaller, hotter, and denser in the past. But here is the key point. Expansion does not mean the universe is expanding into something. It is not like a balloon blowing up inside a room. The universe is not expanding into empty space. Space itself is stretching. That changes everything when we talk about edges. Let us start with a term you need to know: the observable universe. This is the part of the universe we can actually see from Earth. Light takes time to travel through space, so the farthest light we can detect has been traveling for 13.8 billion years. But because space has stretched while that light was moving, the objects that emitted that light are now about 46.5 billion light-years away from us. That makes the radius of the observable universe 46.5 billion light-years, and its diameter about 93 billion light-years. This is often mistaken for the edge of the entire universe, but it is not. It is just the edge of what we can see, our cosmic horizon. Think of it like standing in the middle of a vast ocean on a foggy day. You can only see as far as the fog allows, but, the ocean continues far beyond your line of sight. The observable universe is our foggy horizon. It is not the end of the water. So, if the observable universe is not the real edge, does the entire universe have a physical boundary? To answer that, we need to talk about the shape of the universe. Cosmologists have measured the universe's shape with extreme precision, using data from satellites like the Planck telescope, which maps the cosmic microwave background, the leftover heat from the Big Bang. The results are clear: the universe is almost perfectly flat. What does a flat universe mean for edges? Let us use simple analogies. A flat, infinite sheet of paper has no edges. It goes on forever in every direction. A closed, spherical shape, like the surface of a ball, also has no edges, but it is finite in size. If you walk in a straight line on a ball's surface, you will eventually end up back where you started, never hitting a wall. An open, saddle-shaped universe is also infinite and edgeless. All three possible shapes of the universe, flat, closed, open, share one thing in common: no local edges. There is no place in the universe where you can reach a wall, a barrier, or a sudden end to space and time. This is one of the most mind-blowing facts in modern cosmology. No matter how far you travel through the universe, at 1,000,000 times the speed of light, for trillions of years, you will never hit an edge. You will never find a sign that says, "End of the universe." You might end up back where you started if the universe is closed and finite, or you might keep traveling forever through new galaxies and empty space if it is infinite. Either way, there is no physical boundary. The universe has no outside in the way we think of a room having an outside. Space and time are part of the universe itself. They do not exist outside of it. So if there is no edge, what do people mean when they ask, what is beyond the universe? The question itself might be based on a misunderstanding. But let us push further. Even if our universe has no edge, could there be something else outside of it, something separate from our space and time? This is where theories like cosmic inflation and the multiverse come in. Cosmic inflation is a well-supported idea that says the early universe expanded faster than the speed of light for a tiny fraction of a second after the Big Bang. This rapid expansion stretched space so smooth and flat that it explains why our universe looks the way it does today. But inflation also leads to a wild possibility. Inflation never stopped everywhere. In some regions of space, inflation continues forever, creating new bubble universes every moment. Each bubble is a separate universe, with its own laws of physics, its own Big Bang, and its own stars and galaxies. Our universe is just one bubble in an endless ocean of bubbles, a multiverse that stretches infinitely far. If the multiverse is real, then what is beyond our universe is simply more universe, other bubbles, other realities, other versions of space and time. But these bubble universes are not sitting next to each other in a shared space. They are disconnected, separated by eternally inflating space that stretches too fast for any light or object to cross between them. We can never see or reach these other bubbles, even in theory. To us, they are as unreachable as the edge of our own universe. This is not just science fiction. Many of the best physicists in the world, including those who work at NASA and leading research institutions, take the multiverse seriously because it comes from the math of inflation and quantum mechanics. Let us go back to the original question: what if the universe did have an edge? What would that edge look like? Scientists have thought about this too. A true edge would mean space and time simply stop. There would be no beyond, because there is no space or time to exist there. It would not be empty space. Empty space is still part of the universe. The edge would be nothingness, no dimensions, no matter, no energy, no time. You could not touch it, see it, or travel to it, because reaching it would require moving through space, and space ends at that edge. This idea is hard for our brains to grasp, because we live in a world where everything has an outside. A room has walls, a planet has a surface, a galaxy has a perimeter. But the universe is not like anything we know. It is the container for all space-time, matter and energy. There is no outside the container, because the container is everything. We have sent probes to the edge of our solar system. Voyager 1, the farthest human-made object, crossed the heliopause in 2012, the edge of the sun's influence, and entered interstellar space. But interstellar space is still part of the Milky Way galaxy. The Milky Way is part of the local group of galaxies, which is part of the Virgo supercluster, which is part of an even larger cosmic structure. None of these are the edge of the universe. They are just landmarks in an infinitely large, or finite, but unbounded cosmos. Every time we think we have found a limit, the universe shows us it is bigger, stranger, and more connected than we imagined. Another way to think about it is time. The universe has a beginning, the Big Bang, but does it have an end? If the universe keeps expanding forever, galaxies will drift apart, stars will burn out, and the universe will fade into cold, dark nothingness. But even then, space will still exist, stretching forever. There will be no edge, no final moment, no wall at the end of time. The universe will just be an empty, silent expanse, still without a boundary. If the universe collapses, back in a big crunch, it will shrink into a tiny point, but again, no edge, just a return to the dense state it was in before the Big Bang. What does all this mean for us? We are tiny creatures on a small planet, orbiting an ordinary star, in a single galaxy, in a universe that may be infinite. We may never reach the cosmic horizon, let alone any hypothetical beyond. But the fact that we can even ask these questions, to look at the stars, and wonder about edges and infinities, is one of the most amazing things about being human. We do not need to touch the edge of the universe to understand it. We can use math, telescopes, and the laws of physics to peer into the unknown, to map the cosmos, and to answer the biggest questions ever asked. So, to wrap it up, the universe has no observable edge, no physical boundary, and no outside, in the traditional sense. The observable universe is just the limit of what we can see, not the limit of what exists. The universe is either infinite and flat, or finite and unbounded, like the surface of a sphere. If the multiverse is real, then, beyond our universe is more universes disconnected and unreachable. If not, then there is simply nothing beyond, no space, no time, no existence. The mystery is still unsolved, and that is the beauty of space exploration. Every answer leads to a new question. Every discovery pushes us further into the unknown, and the universe keeps revealing its wonders to anyone who dares to look up and wonder. Please like, comment, share, and subscribe to the channel.